Thank you, Ma'am Grace. To discuss the Week 6 lesson for Mathematics 10 is a graduate of Bachelor in Secondary Education at Laguna State Polytechnic College, San Pablo City, Campus Laguna, and currently taking her Master's of Arts in Teaching Mathematics at Eulogio Amang Rodriguez Institute of Science and Technology. Our Mathematics Coordinator, please welcome Mrs. Thelma F. Pavilion.
Math-sayang araw mga batang mandunong! Handa na ba kayong matuto at mat-aral? I am Teacher Thelma from Isaclopus Integrated School, your math buddy for today. My task is to discuss with you the Mathematics 10 Quarter 2 Module 6 about power theorems. For our competencies, prove and apply theorems on seconds, tangents, and segments. Solve problems involving circles. And for our objectives, number 1, apply power theorem to find the length of the unknown segment formed by chords, seconds, or tangents. Number 2, apply the concepts and theorems on circles to solve word problems. Our topic is all about the theorems on segments formed by chords, second, and tangents, or what we call the power theorems. Number 1, 2-chord power theorem. Number 2, 2-second power theorem. And number 3, second tangent power theorem. Let us recall that chords are segments whose endpoints are points on the circle. In this figure, line segment KR and line segment PS are example of chords of a circle. Our first power theorem is the 2-chord power theorem, which states that if two chords intersect inside a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. To illustrate, in this example, line segment SN and line segment DL are examples of chords that intersect inside the circle at point A. SA times NA equals DA times LA. Now let us solve example number 1. Find the length of AE in the figure to the right. Applying the theorem, we can say that CE times AE equals DE times BE. Substitute its value. 3 times x equals 4 times 6. Multiply, we have 3x is equal to 24. Divide both sides of the equation, we have 3x over 3 equals 24 over 3. The value of x is equal to 8 units. Let us have another example. Find the value of x in the circle. To solve for x, we apply the theorems on intersecting chords. That is, 5 times x plus 2 is equal to 6 times 8. 5x plus 10 is equal to 48. 5x is equal to 38. Divide both sides by 5, so the value of x is equal to 7.6 units. Our second power theorem is all about 2-second power theorem, which states that if 2-second segments are drawn to a circle from an exterior point, then the product of the lengths of 1-second segment and its external second segment is equal to the product of the lengths of the other second segment and its external second segment. AR and NR are second segment drawn to the circle from an exterior point R. AR times IR equals NR times ER. Let us recall some terms that we need for our 2-second power theorem, a second segment. A segment with one endpoint on a circle, one endpoint outside the circle, and one point between these points that intersects the circle. Second, line FD. Second segment, line segment FD. Another term is an external second segment. It is a part of the second segment that is outside the circle. External second segment is line segment TA. Let us try example number 1. Find the value of x in the figure below. Solution, we're going to apply the theorem. So we can say that MO times NO equals PO times QO. To substitute its value, we have x plus 4 times 4 equals 9 plus 6 times 6. Applying distributive property, we have 4x plus 16 equals 90. Simplify, 4x equals 90 minus 16. Divide both sides of the equation by 4, so we have 4x over 4 equals 74 over 4. The value of x is equal to 18.5 units. Let us try another example. Solve for x. By applying the theorem, we have 6 times x is equal to 3 plus 5 times 3. 6x is equal to 8 times 3. 6x is equal to 24. Divide both sides of the equation by 6. Therefore, the value of x is equal to 4 units. For our third power theorem, we have the second tangent power theorem, which states that if a secant and the tangent intersect in the exterior of a circle, then the square of the length of the tangent segment is equal to the product of the lengths of the second segment and its external second segment. In this figure, line segment CD is a tangent segment and line segment AC is a second segment. Therefore, DC squared is equal to AC times BC. Let us recall first what is a tangent segment. A tangent segment is a segment whose one of its endpoints is the point of tangent C. In this figure, line AC is our tangent. Tangent segment is line segment BA and line segment BC. Let us try example number 1. Refer to the circle on the left. If AC is equal to 20 and BC is equal to 5, find DC. By applying the theorem, we can say that DC squared is equal to AC times BC. To substitute, DC squared is equal to 20 times 5. DC squared is equal to 100. Extracting the square root of both sides, we have DC is equal to 10. The length of line segment DC is equal to 10. Let us have another example. Refer to the circle on the left. If DC is equal to 6 and BC is equal to 4, find AB. It is understood that AC equals AB plus BC. Since AB is unknown, we let x equals AB. Thus, we express AC equals x plus BC. Applying the theorem, DC squared is equal to AC times BC. DC squared is equal to x plus BC times DC. 6 squared is equal to x plus 4 times 4. Applying distributive property, we have 36 is equal to 4x plus 16. 20 is equal to 4x. We're going to divide both sides of the equation by 4. So the value of AB is equal to 5. Now that we are acquainted with different concepts and theorems relating to circle, let us apply these learnings in solving word problems. Problem number 1. A central angle of a circle has a degree measure of 68 degrees. What is the degree measure of its intercepted arc? The intercepted arc are also measured 68 degrees, and this is supported by the fact that the measure of the central angle is equal to the measure of its intercepted arc. Example number 2. Quadrilateral ABCD is inscribed in a circle. If the measure of angle A is 73 degrees, what is the measure of angle C? One of the theorems relating to inscribed angle states that if quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Applying that theorem, we have angle A plus angle C is equal to 180 degrees. 70 degrees plus angle C is equal to 180 degrees. Angle C is equal to 180 degrees minus 73 degrees. The measure of angle C is equal to 107 degrees. Example number 3. If a secant and a tangent intersect in the exterior of the circle to form a 24-degree angle, and the lines intercept two arcs in the given circle such that the smaller arc measures 42 degrees. Find the measure of the larger intercepted arc. It would be helpful if you make an illustration of the problem. We have learned that if a tangent and a secant intersect in the exterior of a circle, then the measure of the angle formed is equal to 1/2 the positive difference of the measures of the intercepted arcs. Applying the theorem, we have the measure of angle C is equal to 1/2 the positive difference of far arc and near arc. The measure of angle C equals 1/2 the measure of arc AD minus the measure of arc BD. 24 is equal to 1/2 the measure of arc AD minus 42. Multiply both sides of the equation by 2. We have 48 is equal to measure of arc AD minus 42. 48 plus 42 is equal to the measure of arc AD. The measure of arc AD is equal to 90 degrees. Thus, the measure of the larger intercepted arc is 90 degrees. Example number 4. Two seconds intersect at a point in the exterior of the circle. If the length of one second segment is 20 cm with 12 cm on its external part, how long is the other second segment with an 8 cm length on its external part? Let us first illustrate the problem to better visualize what is given, according to the 2-second power theorem. If 2-second segments are drawn to a circle from an exterior point, then the product of the lengths of one second segment and its external second segment is equal to the product of the lengths of the other second segment and its external second segment. Apply this theorem, we have 32 times 12 is equal to x plus 8 times 8. Applying distributive property, we have 384 is equal to 8x plus 64. 320 is equal to 8x. Dividing both sides of the equation by 8, the value of x is equal to 40. Thus, the length of the second segment is x plus 8 equals 40. 40 plus 8 is equal to 48 centimeters. Problem number 5. refer to circle O with the radius OX and the tangent PX. Find OP. To solve this problem, we need to apply the theorem that states that if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. Conversely, if a line is perpendicular to the radius at its endpoint on the circle, then the line is tangent to the circle. That is, line segment PX is perpendicular to line segment OX, and angle OXP is a right angle. To solve for line segment OP, we will be applying the Pythagorean theorem, since the triangle formed is a right triangle. OP squared is equal to OX squared plus PX squared. OP squared is equal to 4.3 squared plus 6.8 squared. OP squared is equal to 8.49 plus 46.24. OP squared is equal to 64.73. Extracting the square root of 64.73, the measure of line segment OP is approximately equal to 8.05 centimeters. Example number 6. Circle O is inscribed in triangle PQR. Find the perimeter of the triangle. To solve this problem, we need to apply the theorem that states that if two segments from the same exterior point are tangent to a circle, then the two segments are congruent. Based on the theorem, we can say that line segment PA is congruent to line segment PB. Line segment RC is congruent to line segment RB. Line segment QA is congruent to line segment QC. Thus, PB is equal to 15 cm, RC is equal to 17 cm, and QA is equal to 11 cm. To find the perimeter of the triangle means to add the length of all the sides. The perimeter of triangle RQP is equal to line segment RQ plus QP plus PR. RC plus CQ plus QA plus AP plus PB plus BR. Substitute, we have 17 plus 11 plus 11 plus 15 plus 15 plus 17. We have 28 plus 26 plus 32. Therefore, the perimeter of triangle PQR is equal to 86 cm. Once again, I am Teacher Thelma, always happy and ready to serve, from Greater ILIS, saying, better your best. Thank you for watching.